All right, in this video, we're going to check out, prove that by finding the determinant of this matrix right here, we can find that we can find the equation of a line that passes through 2 points. So first thing we're going to do is let x1, y1 and x2, y2 be unique points. If we want to get super technical, we should probably specify that x1, y1, x2, and y2 are all real numbers, but I think that this is probably formal enough for our purposes. So what we want to do is we just want to write the equation of the line that passes through these two things based on these being the coordinates. So we know that we can find slope, and we can find slope by taking y2 minus y1 and dividing that by x2 minus x1. So using that and plugging into point slope form, so using point slope form, we can now write the equation of a line based on our slope and one of these points. So using point slope form, the equation of our line that passes through these 2 points x1, y1, and x2, y2 is, so let's write the equation. It's going to be y minus y1 equals our slope times x minus x1. So we've got the equation of this line, and it's written in point slope form. That's a little more kind of known to us, a little more familiar to us. So what we're going to do is we're going to take this equation and we're just going to kind of manipulate it. So the first thing that I want to do is I want to get this x2 minus x1 out of the denominator. And in order to do that, I want to multiply both sides by that quantity, x2 minus x1. When I do that, my left side, this is a binomial, and a binomial times a binomial, I know I have to FOIL that. So that's going to be x2. I'm going to actually write it as y times x2 minus y1 x2. That's the first and the outer. The inner is minus y x1. And then the last is going to be plus x1 y1. So that's my left side. My right side, this is really just going to cancel. And so I'm going to be left with the numerator here and then this quantity right here. So that's equal to y2 minus y1, that quantity, times x minus x1. So what do we do to do that? We multiplied both sides. So multiplying both sides by x2 minus x1, we get this expression. Okay, and again, the reason that we did that is to get rid of this fraction, get rid of the denominator in that fraction. All right, so the next thing that we want to look to do is expand and collect some like terms. And so let's go ahead and do that. Expand the right side, and we end up with, first is x, y2. Outer is minus x1, y2. Inner is minus x, y1. And then the last is plus x1, y1. And then our left side just kind of comes down. So let's go ahead and try to copy that. Nice and easy. Technology is nice sometimes. So let's check out what's going on. So at this point, we've just got a bunch of, like, a big mess of terms. And so sometimes it kind of pays to step back and think about, where am I trying to go with this thing? And maybe that can help us figure out what we need to do. Well, where we're trying to go with this thing is we're trying to go toward the determinant of this, because our claim is that if we take any 2 points, the determinant of this thing will give us the equation of the line. So let's check out what the determinant of the thing actually looks like, and maybe that'll give us something to work toward. So if we look at the determinant of x, y1, x1, y1, 1, x2, y2, 1. If we look at the determinant of that, then I know I've got x times y1 minus y2 minus y times the determinant of x1 minus x2 plus 1 times the determinant of x1, y2 minus x2, y1. So these are some things that we're trying to look for, and you can kind of hopefully see at this point that if you were to distribute these things out, you're going to get a bunch of the ugly stuff that we have in there. So let's go ahead and try to manipulate what we have into that expression right there. First thing hopefully that you see is you got an x1, y1 on both sides, so we can just cross that off. Those are going to cancel. So the first thing that we're looking for are x terms. So let's go ahead and take our x terms over here. We're going to move everything to the left side. So I've got a negative x, y2 when I subtract this, and a positive x, y1. So let's call this x, y1 minus x, y2. Move that down a little bit. So we've taken care of those guys right there. So the next thing we want to look for are what are the terms that have just a single y in them. So here's one. So we've got a plus y x2. And then the other one's right here. So we've got a minus y x1. So I've taken care of those. A couple terms that are left over. I've got this guy right here, minus x1, y2. And if I add that to the other side, I'll get a plus x1, y2. And then over here is the last one, and that's minus x2, y1. So I just kind of rearranged things. And this is all equal to 0 because I kicked everything over to that side. So we're almost to where we need to be. So let's check this out. Remember, what we want to get to is something that looks like this, because that is the determinant of that matrix. So in order to get to that, I need to have an x out front of a y1 minus y2. Well, that's easy. Just factor out an x. But what I'm left with on the inside is y1 minus y2. So that's done. The next one is I need a y times an x1 minus x2. But right now I've got an x2 minus an x1. But notice, remember, our signs alternate on our determinant. So if I want to factor out a negative y, that's going to turn this term negative on the inside. So I'm going to have a negative x2, and that's going to turn this term positive. So I'm going to have a positive x1, and that's exactly what I need. I need a minus y times the quantity x1 minus x2. Last one is exactly what we need. It's exactly what we need. So we need a plus 1, technically. If we factor out a 1, it doesn't change anything, times x1, y2 minus x2, y1, and that's equal to 0. Okay, so last thing is we just want to turn this into determinant form just to really solidify that we got what we needed. So if I take y1 minus y2, well, that's the same thing as saying that's x times the determinant of a matrix that looks like this: y1, 1, y2, 1. And if we look back up at our original, well, I know that when I take my x, I cancel out this column and this row, and that's exactly what I have here left that I'm taking the determinant of. So the next one, similarly, we're going to subtract y, and we're going to take the determinant of whatever that is. So that's x1, 1, x2, 1. There's our matrix there. And then the last one is going to be a plus 1 times the determinant of the matrix x1 and y2, because that's our first product. And then the second part is going to be x2 goes down here, and we multiply that by y1 up here. And that's equal to 0. So usually we end with a therefore with a conclusion. Our conclusion really is just a restatement of what we had up here, because we just showed that that if we take the determinant of this thing, that we got the determinant of this thing out of the equation of the line that goes through those 2 points.